So we're going to start with grade 9 maths. So you can find all the lessons on aplusstudents.com. You can find all the lessons on aplus.com, aplusstudents.com. So you have to log in there using your email address and password as provided by the administrator. Then you have to select math from the subject. You have to scroll down to grade 9, and then we are going to start with the topic that is chapter 3 measurements. So we are already working on the chapter. So we are going to start with the topic minimum and maximum area and volume. So let's go to the chapter measurement, and then we have to start with the topic that is minimum and maximum area and volume. So let's start with the topic minimum and maximum area and volume. Please make sure you have your notebook and pencil so that you can note down the important points. Got it? Okay, let's just start with a lesson that is minimum and maximum area and volume. Okay, so let's start with examples. Okay, the rectangular prism, you are given with the rectangular prism. Below, the rectangular prism below is labeled with its measured dimensions. Taking measurement error into account, what is the minimum and maximum possible values? Okay, so let me draw the prism. Okay, it looks like this. So this is 17 yards, this is 7 yards, and this one is 3 yards. So we need to find the minimum and maximum volume taking measurements error into account. So basically we have to find the minimum and possible volume. Okay, first find the greatest possible error. Each measurement was made to the whole numbers. All of the numbers are whole number, like 17, 7 and 3 yards. All the numbers are whole numbers. That means the greatest possible error is 0 0.5 yards. Got it? So we just did this one in the last you can find the lesson in the chapter, the same chapter, that is greatest possible error. We did the chapter in the last session, so you can find the session on uh, a plus 2. You can find it on the channel A plus students. Okay, so the greatest possible error is 0 0.5 in this case, because all the numbers are whole numbers, so it would be then half of one, that is 0 0.5 yards. Got it? So we know that the maximum area volume is length time width time height. So for each of the value you have to add the greatest possible error. So the length is 17, so just add 17 plus 0 0.5. The width is 7, so just multiply, just add 3 plus 0 0.5, and then the height is 7, so you have to do 7 plus 0 0.5, so just add 17 plus 0 0.5 is 17.5, 3 plus 0 0.5 is 3.5, and 7 plus 0 0.5 is 0 0.5. So just multiply all the numbers. So the numbers are 7.5, 3.5, and 17.5. The volume is 459.307, and we have to find the minimum value also. So for the minimum value, you have to subtract zero point 0.5 from each value. Got it? So for the minimum value, you have to subtract. You have to do same thing, length time, width time, height, but now you have to subtract zero point 0.5 for each value. Got it? From each value, because you have to find the minimum volume also. So just subtract them, and it will be then 16.5 times 2.5 times 6.5. So when you multiply all the numbers, that equals 268.125. So the minimum possible volume is 268.125, and the maximum possible error is 459.375. Got it? So basically, to find the minimum possible volume, you have to subtract the greatest possible error from each measurement before calculation, like we did. For the maximum value, what we did, we added the maximum greatest possible error in each value and we multiplied them. And for the minimum value, we subtracted the greatest possible error value from each value and then we subtracted them, multiplied them. Got it? Okay, let's do another example. You are given with a rectangle. This one is 16 inches and this one is 14 inches. So let's just calculate the greatest possible error. So both the values are whole numbers. So the greatest possible error is half of 1 inch, half of the unit. So basically the greatest possible error is 0.5 inch. Got it? So you have to find the minimum and maximum possible area. So the area for the rectangle is length time width. So for the maximum value, you have to add the error in each value. So 16 plus 0.5 and times the width is 14 plus 0.5. Got it? So just multiply them, 6.5 times 14.5. So it would be then 239.25. Got it? And for the minimum value, you have to subtract the greatest possible error from both the values. 16 subtract 0.5 and 14 subtract 0.5, and then you have to multiply them. Got it? So 16 minus 0.5 is 15.5 and 14 minus 0.5 is 13.5. So it would be then 209.25. Got it? So this way you can find the maximum area and the minimum area. Let's just start with the test button. So let's do some practice question. Okay, so the first one is the one we just did on the board. So the values for the one are 209.25 and 239.25. Got it? So select the correct values and click on the OK button. Okay, the second one is we are given the rectangular prism, and the rectangular prism is, okay, it looks like this. This is 8 feet, this is 10 feet, and the height is 18 feet. So you have to find the minimum maximum possible error and volume and minimum possible volume. So all the values are the whole numbers, so that means the greatest possible error is half of the unit. So 1 by 2 is 0.5. It would be then 0.5 feet. Got it? So for the maximum value, you have to add the greatest possible error in all the values and you have to multiply them. Now you have length time, width time, height. So the length is 18, the length is 8, so just add 8 plus 0.5. For the width, you have to do 10 plus 0.5, and for the height you have to do 18 plus 0.5. Then you have to multiply them. So it would be then 8.5, 10.5, you have to multiply them, not, and then 18.5. So just multiply them, and that's the value for the maximum volume. Got it? So let me just use it, check it on the calculator. So they are 8.5 times 10.5 times 18 18.5. So it is 1651.25. And for the minimum volume, you have to subtract the greatest possible error from all the values, and then you have to multiply them. Got it? You have to do 8 minus 0.5, then 10 minus 0.5, then 18 minus 0.5. So when you subtract them, they are 8 minus 0.5 is 7.5, 10 minus 0.5 is 9.5, and 18 minus 0.5 is 17.5. Just multiply all the values. So 7.5 times 9.5 times 17.5, it is 1246.875. Got it? So these are the values for the greatest possible maximum volume and minimum volume. So just select the correct option, that's the first one, and click on the OK button. Got it? Okay, let's just do another one. So the next one is, you are given with a rectangular shape. The rectangular shape is, the dimensions are 14 meters and 12 meters. So again, the greatest possible error is half of the unit. So half of unit is 1 by 2 is 0.5 meters. Got it? So for the you have to find the area. So area is length time void. So for the maximum area, you have to add 0.5 to each value. So 14 plus 0.5, and for width 12 plus 0.5. So it would be then 14.5 times 12.5. Got it? Just multiply them. So 14.5 times 12.5, so it is 181.25. Got it? And for the minimum value, you have to subtract the greatest possible error from both the values, and then you have to multiply them. You have to do 14 minus 0.5 and 12 minus 0.5. So 14 minus 0.5 is 13.5, and 12 minus 0.5 is 11.5. So you have to do 13.5 times 13.5 times 11.5. Got it? So it would be then 155.25. Got it? So select the correct option and click on the OK button. Got it? So you can, I'm just moving on to the next lesson. You can complete the topic by yourself later today. If you have any problem with the topic, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9. Got it? Okay, let's start with the next topic. So the next topic is percent error, area, and volume. Okay, percent error, area, and volume. Okay, let's start with the example. The rectangular prism below is labeled with its measured dimensions. Taking measurement error into account, what is the percent error and its calculated volume? Okay, you are given with a prism. So the prism looks like this. Okay, this is 10 feet, this is 17 feet, and this is 18 feet. So first you have to, so basically we have to find the percent error in the volume. So we have to follow three of the steps. The first one is we have to find the measured volume. Step one is find the measured volume. Just multiply all the values with the formula as it is. V equals length time width time height. So the length is 10 times 17 times 18. So when you multiply all the values, they became 3060. Now find the minimum and maximum possible volume. So step 2 is find minimum and maximum volume, and we know how to find them. We just did this on the topic. So find the minimum and maximum volume. So for the maximum value, you have to add the greatest possible error. So the values are the whole number. So the error is 0 0.5. Greatest possible error is 0 0.5. So for the maximum value, you have to add the 0 0.5 in all values. So just add them. 10 plus 0 0.5, 17 plus 0 0.5, and 18 plus 0 0.5. Got it? So multiply all the values and find the value. So it would be 10.5 times 17.5 times 18.5. So just multiply all the values. So it would be then 3339 point 3,399.375, and now find the max minimum value. So the minimum is you have to subtract the greatest possible error from both all the values. So 10 minus 0 0.5, 17 minus 0 0.5, and 18 minus 0 0.5. So it would be then 9.5, 16.5, and 17.5. So when you multiply them, it would be 2,413.0125. Okay, now you have to find a greater difference in volume. You have for the difference in volume, what you have to do, subtract both the differences. Subtract both the volumes. One of them is the subtract the measured volume, that is actually the original value. You can say the measured. Subtract the measured value from both the values, the minimum and the maximum. Let's just see what happened. Just subtract the measured value minus the minimum value. The measured value is 3060 minus the minimum value is 2743.125. So it would be then 316.875. Now same, you have to subtract the measured value from the maximum value. So it would be then, you have to subtract the maximum value out of the measured value. Got it? Subtract the maximum value out of the measured one, because maximum value is the greater value. So you have to subtract V max minus V measured. So the max, this one is 3399.375 minus 3060. So the value is 339.25. Okay, so the value is 339.375. Now you have to find the percent error. So what you have to do for the percent error, you have to divide the greatest possible error in volume by the measured volume. So the greatest possible error, that is V max minus V measured, it would be 339.375. and the measured volume is 3060. Got it? So just divide them, and the value is 0.1109. So you can multiply the value with 100, just multiply this value by 100, so it will be then 11.09. So that means you can round off the number, that means the greatest possible error is 11%. Got it? So it's a bit long procedure, but the things are very easy. Let me just explain once again, just listen to me carefully. So what you have to find, you have to find the percent error in the volume. So how to find the percent error? What you have to do for the this one, you have to follow three steps. The step one is you have to find the measured volume. Measured volume is you have to just multiply the original volume, that is v equals length time width time height, just multiply all the values as it is, so the measured volume is 3060. Got it? Okay, then you have to find the maximum and the minimum values volume. So we know that how to find them. We just did this topic earlier. So for the maximum and for the minimum value, you have to, for maximum value, you have to add the greatest possible error in all the measurements and then have to multiply them. Like you find the volume, just add the extra thing is you have to add the greatest possible error. Got it? Then find the minimum volume. You have to subtract the greatest possible error this time. So then you have to find a difference in the volume. Subtract the measured volume out with the minimum value and subtract the maximum value with the measured volume. And then you have to find the percent error. So for the percent error, you have to find the greatest possible error in the volume divided by the measured volume. Got it? And then multiply the value with the 100. So it would be then 11.1%. Got it? Okay, let's just do another example because it's a bit long method, so we are going to just do one of the example on the board so that we can move on to the next lesson. Got it? Okay, the first topic, the next question is a rectangle. Okay, we are given with a rectangle that is 3 centimeter and 19 centimeter. What is the percent error in its calculated area? So we have to find the percent error in the calculated area. So first we have to find the step one is we have to find the measured area. Step one, find measured area. So with the area of the um, rectangle is length time width, so just multiply the values 19 times 3, so it would be then 57. Okay, step 2 is find the minimum and maximum area. Find minimum possible area and maximum possible area. Minimum possible area and maximum possible area. And you know that how to find them. The greatest possible error is the both the values are the whole numbers, so the greatest possible error is 0 0.5. So just add and subtract in both cases. So in the case of maximum, sorry, area, maximum, not volume, area, you have to add them. Just do 19 plus 0 0.5 and then 3 plus 0 0.5, so it would be then 19.5 and times 3.5. So just multiply both the values. So let me just use the calculator. Okay, 19.5 times 3.5, it is 68.25. Now find the minimum area. So for the minimum area, you have to subtract the greatest possible error. So it is 19 minus 0 0.5 and 3 minus 0 0.5. So it would be then 18.5 and 2.5. Just multiply them. 18.5, 18.5 times 2.5, it is 21. Sorry, you have to multiply them. 18.5 times 2.5, it is 46.25. Okay, now you have to find the um, now you have to find the greatest, find the difference, greater difference in area. So to find a difference in area, you have to subtract the measured area minus the minimum area, and then maximum area minus the measured area. Got it? So the measured area is 57. So 57 minus 46.25 and 68.25 minus 57. So 57 minus 46.25 is 10.75 and it is 11.25. So calculate now, find the greatest possible error. So the greatest possible error is divide the greater value. The greater one is 11.25. So divide the 11.25 by the measured wall area. So so to find the percent error, you have to do the percent area. You have to divide the greatest possible error in area by the measured area. So the greatest value is 11.25 and divide it by the measured area. Measured area is 57. So 11.25 divided by 57 is 0.197. So just multiply the value by 100. So it would be the 19.73. You can round off the number to the 19.7. So that means the greatest possible error is 19.73. Got it? So I'm moving on to the next lesson. You can complete the lesson test by yourself later today or anytime right before the next session. So please, if you have any problem with the topic, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9. Got it? So the next topic is percent area. Okay, the next topic is percent area. Let's start with an example. What is the percent area for the measurement of two pins? Okay, so the measurement we are given is two pins. We have to find the percent area in this one. Got it? So first find the greatest possible error. The measurement of two pins was made to the nearest whole pin. So that means the greatest possible error is for the whole numbers it is 0.5 always. Got it? Okay. So for the percent area, what you have to do, you have to divide the greatest possible error by the measurement. So the greatest possible error is 0.5 and divided by 2. Got it? So 0.5 divided by 2 is 0.25. So just multiply 0.25 by 100. So it would be then 25%. Got it? So what you have to do when you have to find a percent area in a measurement, you have to find the greatest possible error. And for the whole numbers, the greatest possible error is always 0.5. So divide the greatest possible error with the measurement given. So the greatest possible error is 0.5 and the measurement given is 2. So just divide 0.5 by 2. It would be 0.5. Multiply the value with the 100 because you have to find the percent area. So it would be then 25%. Got it? Okay, let's start with the test. So the first question is find the what is the percent error for a measurement of 5 yards. Okay, so you are given the measurement that is 5 yards. You have to find the percent error for this one. Got it? So for the percent error, what you have to do, you have to find the greatest possible error first. So the greatest possible error for the whole numbers is always, yes, it is always 0.5. So it is 0.5. So for the percent error, what you have to do, you have to divide the greatest possible error divided by the measurement. So the greatest possible error is zero point 0.5 and the measurement is 5. So you have to divide zero point 0.5 by 5. It would be then 10. So you can write the answer as a percentage form. So that means the greatest possible error is 10%. Got it? Let's do another test question. Select the correct option and click on the OK button. Okay. Write the percent error in measurement of 2 milliliters. So measurement is 2 milliliter. So first you have to find the greatest possible error. So the greatest possible error for whole numbers is always zero point 0.5. Keep this very important point in your mind. So for the percent error, what you have to do, for the percent error, you have to divide the greatest possible error with the measurement. So the greatest possible error is 2 and the measurement is zero point 0.5. It would be then 0.25 and multiply it with the 100 because you have to write the value in the percentages. So it would be then 25%. Got it? Okay, just click on the back. You can complete the test by yourself later today. If you have any problem with the topic, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9 p.m. Got it? So just click on the back button so that we can do the next lesson. The next topic is the final test for this chapter. So let's start with the final test. Where is the final? Just 1 minute. Let's go to the final test, maths. Then you have to scroll down to grade 9. We are doing a chapter measurement. But you don't have the final test for this chapter. But why? Okay, let me just send a message to the administrator so that they can check the chapter measurement grade 4, grade 10. Okay, we can do the practice questions for the topics we did today. Don't worry. Okay, let's start with just like go back to the first topic. We've started with minimum and maximum area and volume. Let's do two of the practice questions for this topic. Okay, let's start with the minimum, maximum, and minimum volume, and let's do practice question. Okay, let's do. Okay, we have done with this one. The first option is the correct one. Okay, for this one, I think that is the correct option because we did this on the board earlier, and I don't want to repeat these one. I want to do the. Okay, let's just do this one. 14 and 12. We then did this one also. This is the correct option. If I'm not wrong, yes, the second one is the correct answer. Okay, let's do the third one on the board. Okay, the rectangle below. Okay, so you are given 5 feet and 4 feet. We have to find the minimum and the maximum possible areas. 5 feet and 4 feet. Okay. Okay, this is 5 feet and this is 4 feet. So you have to find the greatest minimum and maximum possible areas. Okay, we have to find minimum and maximum possible area. Okay, let's just find the area of the one minimum and maximum area we have to find. So let's just find the maximum area. We know that the dimensions are the whole numbers, so that means the greatest possible error in this case is 0 0.5. Got it? In the case of whole numbers, the greatest possible error is always 0 0.5. Got it? So just for the maximum value, you have to add the area both in the dimensions. Area is length time width. So 5.0.5, and for the width you have to do 4 plus 0 0.5. So it would be then 5.5 and 4.5. So just multiply both the values. So 5.5 and 5.5 times 5 point, okay, 5.5 times 4.5, it is 24.75. Got it? And for the minimum area, you have to subtract the um, greatest possible error from both the values. So 5 subtract 0 0.5 times 4 subtract 0 0.5. So it would be 4.5 times 3.5. So 4.5 times 3.5. Got it? So it is then 15.75. So the values are 24.75 and 15.75. That's the second option. Select the correct option and click on the OK button. Got it? Okay, let's do. Okay, let's do the topic. Let's do the practice questions from the next topic, that is percent area and volume. Got it? Okay, let's start with a test. So I think we have done two of the questions. So let's start with the third one. Mm, okay, so let's do again. I forgot the answer for this one. I think that's 19.5%, but let's just do it again. Okay, it is the rectangle given below is labeled with its measured dimensions, taking measurement errors into account. What is the percent error in its calculated area? Okay, so let me draw the 3 and 19 centimeter it on board. 3 centimeter and 9 centimeter. Okay, so let's start with the first step, that is we have to find the measured volume. Step 1 is find the measured volume. Okay, so the measured volume is multiply the values as it is. We have to find the area, sorry, not volume. Find the measured area. So find the area measured. So it is length time width. So length time width is 9 times 3 and it is 27. Got it? Okay, for the second step, we have to find the minimum possible. Find the minimum possible area and maximum possible area. Step 2 is we have to find maximum area and the minimum area. So for the maximum area, we have to add the greatest possible error. So greatest possible error is 0 0.5 in this case, because the given values are the whole numbers. 3 and 9 are whole number. So in the case of whole number, it would be then 0 0.5. So aim for maximum area, you have to add zero point 0.5 in both the measurements. So 3 times 0 0.5 and 9 plus 0 0.5. So it would be 3.5 and 9.5. So 3.5 times 9.5 is 33.25. And for the minimum value, just subtract 0 0.5. So 3 subtract 0 0.5 and 9 subtract 0 0.5. So 3 subtract 0 0.5 is 2.5 times 8.5. 2.5 times 8.5. It is 21.25. Okay, now for the we have to find a greater difference in volume. We have to find the step 3 is you have to find the greater difference in area. So you have to do area measured, subtract the minimum area, and you can subtract the maximum area out of the measured one. Let's see who has the greater value. So measured is 27 minus 21.25 and 33.25 minus 27. So let's just calculate the value. So 27 minus 21.25 is 5.75 and 33.25 minus 27 is 6.25. So this is the greater value. Just divide 6.25 by the measured area. The percent area formula is the greatest possible error, the greater difference in the area divided by the measured area. Got it? So divide 6.25 by 27. It would be then 6.25 divided by 27 is it would be then 0.19%, and that is 19 point, it is then 19%. Got it? So select the 19.5%, sorry it is. So select the correct option and click on the OK button. Got it? So that's all for today. We have done 4 of the topics today. The topics are the topics we are doing are the minimum and maximum area and volume. It's in chapter 3 measurement grade 9. So it is in minimum and maximum area and volume, percent area, percent error area and volume, and percent error. So you have to complete the lessons by tests by yourself later today. If you need more help with the topics, you can contact any tutor on the Skype. They are available Monday to Friday 5 to 9. Got it? So that's all for today. See you in the next class. Bye.